Hello Internet. In this video I thought I'd go over a basic simplification of a square root of a number. This particular problem comes from OpenStax Intermediate Algebra textbook, which if you haven't already checked out OpenStax and their work, they're basically giving away free textbooks. They're creating them and giving them away for free. So it's a pretty sweet organization and I certainly appreciate their work. Link in the description if you're at all interested. This particular problem is Intermediate Algebra Section 8.2, Exercise 59, and we're asked to use the product property to simplify radical expressions. Well, this is a radical expression. In this case, it's just a number. This is the square root of a number. That number doesn't happen to go evenly. In other words, it doesn't happen to have a perfect, or the number itself is not a perfect square. And you can kind of see that immediately by going the square root of 147. If you do that, you will get something with a whole bunch of decimals. That indicates that 147 isn't a perfect square. So what I see a lot of students doing right off the bat is they write 147, and then they try and factor it into something like 7 times, so I don't know, 147 divided by 7. I know it goes even. Yeah, 21. So they try and factor it into as small as possible. I suppose you could do that, but there's an easier way. And so the students aren't wrong to say that 147 does in fact divide by 7 and 21. It does. 147 is divisible by 7. It's 21. There's nothing wrong with that. It's just that that isn't particularly helpful in the context of this problem. And the reason why is because the goal of this problem is to divide the 147 by the largest perfect square that can possibly be pulled out of it. And in order to kind of see that, we really need a list of perfect squares. So I'll go ahead and make a list of perfect squares now. So I'm going to write this a little bit backwards, and you'll see why in a second. So what's 2 squared? 2 squared is 4. Normally, you'd write it here, but again, I'm writing it backwards, and you'll see why in a second. So 3 squared is, 2 times 3 is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared, I think, is 64. I don't know. 8 squared, yeah, 64. And so on and so forth. You could easily fill in the rest of this table on your own by just using a calculator, or if you know the multiplication tables really well, you can certainly, it's relatively easy to fill in this table on your own. So anyway, you get the idea. These are, if basically this table represents this squared ends up here. However, the reason I wrote it backwards is because this table also represents the square root of this number, or the principal square root of this number, is this. So when you are able to pull out, say, 25 or something, it will come out as this number, which is, now you can see kind of why I wrote it backwards. So basically, if you see one of these numbers in this number, you can pull it out as one of these numbers. So let's go through that. So basically, we're going to take 147, and we're going to start dividing it by not like 2 or 11 or 3 or something. We're going to divide it by values that are on this list here. Not this list, this list. So 147 divided by, does it divide by 4? It doesn't divide by 4 evenly because we got decimals. So let's keep trying. Divide by 9. And in this process, I'm going to keep going through and figuring out the highest one that goes evenly until I get an output, a result here of, say, less than 2. Because if it's less than 2, that becomes kind of arbitrary. I mean, you can keep dividing it, but it really isn't much of a point to that. So it doesn't divide by 9 evenly. Let's go 16. Notice I'm not immediately going from like 9 to like 11 or something. I'm not trying 11 because 11's not a perfect square, so it wouldn't be really. It may divide by 11. I don't know, but it's not particularly helpful to divide it by that 11. That also did not work, so let's keep going. What's the next perfect square? 25. That doesn't work either. 36 also doesn't work. 49. 49 does work. Okay, so therefore we can rewrite this as 147 factors into, what did we say? 49 and 3. Now, do we know that that's the highest one that we can pull out? Well, we're not sure yet. Let's keep trying. 147 divided by 8. No, not 8. I basically just made the mistake that a lot of students make. They start dividing by these numbers. It's not going to help you. It's not a perfect square. Divided by 64. Okay, so I could keep going, but at some point we're going to get below 2. Actually, I'll just go ahead and keep going just for the heck of it. 9 squared. See, if I divide by whatever 9 squared is, 81 probably. Right? Let's try that. 81, right? Yeah, so see, I'm going to get something that's below 2. That tells me that there's no point in continuing because this number is below 2. So our 3 there, whatever that divided by, was the correct answer. And you can check that by doing this. So it was 49, was the highest perfect square that we can pull out of this number. So that verifies that basically we can't pull anything above 49. There are no perfect squares above 49 that we can pull out evenly from 147. So now that we have that information, we can carry on with the rest of the problem. So let me rewrite the original problem. So square root of 147. I'm going to write a little line here because that was our work to get to this point. So that's going to become the square root of 49 times 3. So you can see that I'm breaking it up as the perfect square times the bit that isn't the perfect square. These two would multiply back together to get 149, but we're breaking it up this way because this is a perfect square. So to carry on here, we would have, we can break it up as square root of 149, not 149, I keep doing that, 49 is what I mean, times the square root of 3. So this is actually a value. We can get a square root of 149. We can just see it here. Square root of 49 is 7. So this can become 7 square root of 3 because this ended up being the perfect square that was able to be pulled off of this, and this remainder, basically this other factor that isn't a perfect square, needs to stay there because it can't be divided into, there's no perfect square that you can divide 3 by that will factor out other than like 1, and 1 for this, in the context of this type of thing, 1 is arbitrary. Anything divides by 1. That's easy. So anyway, I believe that is the answer to this problem. Alright, I think that is all for this video. I hope you have enjoyed it. If so, please like and subscribe. Also, consider hiring me as your tutor. I'd be happy to help you with stuff like this. For more on that, check out my website at www.tutoringbyroger.com. Thanks again for watching and have a great rest of your day.